Hi guys, welcome back. Have you ever wondered why I wave? It's my visual cue for when to, start trimming the video. Anyway, on to section 3 of chapter 14. We're going to start talking about the atom today. We're going to go into some history. It's going to feel like a history lesson a little bit, but since I'm not a history teacher, bear with me. All right, so a long time ago, there was this dude named Democritus, and that's him right there, a little bald guy. He's from so long ago, we don't actually have any photographs of him. But before I tell you about Democritus, I just want you to remember the definition of atoms from a previous lecture. They are the smallest piece of an element that you can have, okay? The smallest piece of carbon you can have would be a single atom of carbon, but they are not the smallest piece of matter you can have. Atoms can actually be broken up into smaller pieces, okay? But anyway, back to this guy, Democritus. He was a Greek philosopher, not even a scientist. Philosophers used to just think about the world and how things work, and it was kind of like an early form of science. Well, he's the first guy that suggested that all matter was made up of these tiny invisible pieces that we couldn't see. They were too small to see. This was back in 440 BC, before Christ, that they were actually coming up with this idea. It's pretty cool. He came up with the word atmos, which is a Greek word that means unseparatable or indivisible, okay? So the thought was that these small particles of matter could not be broken down any smaller. It's been proven wrong, but still not bad for 440 BC, right? All right, then we move on, and we get into the 1800s, early 1800s. We've got this guy named John Dalton, and he came up with his atomic theory. And he had several points, many of which that are still used today. A lot of things have been proven to be very accurate, some not so much, okay? His first idea was that elements are made of atoms. That's true. The atoms of each element are different from each other, okay? He said that atoms are indivisible and they can't be destroyed. That's since been proven wrong. We now know what the individual pieces of the atoms are. The thing is when you start breaking those atoms up into their individual pieces, then they're no longer identifiable as an element, okay? They're just random pieces. Like an electron is an electron. It doesn't matter if it's an electron for helium or for gold, okay? But when those electrons are together in an atom of gold or helium, then the element is identifiable, okay? All atoms of an element are the same. That's not really true either. There's this thing called isotopes. You can have slightly different numbers of pieces of things in the atoms. We'll talk about that when we get to our chemistry section. They're still considered the same element, but they're slightly different from each other, okay? But still not a bad idea for him to come up with in 1802. Atoms of different elements differ in mass. That is true. That's how our periodic table is arranged, is according to the mass of the elements. And then atoms combine chemically to consistent ratios. What that means is, for instance, like H2O, okay? Well, in order for you to have the compound water, you always need 2 atoms of hydrogen to every 1 atom of oxygen. So that ratio of 2 to 1 is consistent for that compound. Same thing with any other compound that we deal with. They're combining in those consistent ratios, okay? So that's true. And then he had this idea that was known as a billiard ball model. He thought since atoms were indivisible, that they were just these solid balls of material. And all the stuff that made the atom was crammed together in a dense solid ball, and it could not be separated, okay? Well, we've gone past that, and there's been all kinds of other theories that have come up, all kinds of different models, okay? One was this guy named Thomson. He came up with what was known as the plum pudding model. Now, we don't have plum pudding here in America, but if you're familiar with fruitcake, it's very similar to plum pudding, okay? His thought was he knew that there was like negative and positive charges to these atoms, but he also knew for the most part that they were neutral. So the negative and the positive particles had to cancel each other out. So he thought that these negative electrons, these small particles, like the chocolate chips in a muffin, were surrounded by a solid positive matrix of some other substance, okay? So like the fruit in a fruit cake, that'd be the negative electrons, and then the cake itself would be the solid positive substance, okay? Or again, blueberries would be the negative electrons, and the muffin itself would be that solid positive substance. That's been proven wrong. Then we came to Rutherford, and he came up with what's known as the planetary model. And you've probably seen this kind of a picture before. Whenever we talk about atoms or anything like nuclear, you see this kind of a picture right here. And his thought was that the electrons were actually orbiting around a nucleus in the atom. And he was really on to something. He was really kind of on the right track here. But it's been proven to be a little more complex than that. So then we come to this guy named Bohr. The Bohr model is that the electrons don't just randomly fly around the nucleus, but they have orbital rings, okay? And it gets a little more complicated, and we're going to talk about it a little bit when we get to the periodic table. But there's something about the energy level in these rings, and so the electrons like to stick to those distinct orbit rings, okay? Now, much of his model is still used today, but they've kind of come up with this quantum mechanical model that is just way beyond us. Like, that's my brain right there, okay? And it's way more complicated than those rings of the Bohr model. It's these clouds, and these electrons can be in different shapes, but you don't ever really quite know where those electrons could be. You get some of these funkier shapes like what's represented in that poster there. We are not going to get into that level. You might start learning about that if you take high school physics. Certainly if you're taking physics in college, you'll be talking about that, okay? All right, let's talk about the size of the atoms. They are tiny, tiny, tiny. I found this little poster here. It says there are more atoms in a single grain of sand than there are actual grains of sand on the Earth, okay? Now, you've been to the beach. You know how many grains of sand are in a single beach. If you pick up one of those tiny grains, it's said, I don't know how scientifically accurate this is, it might just be a model to make your head explode, but it's said that there's more atoms in that single speck of sand than there are actual specks of sand on the entire Earth, okay? So here's some other examples. A piece of paper is about 10,000 atoms thick, okay? There are that many atoms in a single cell. What is that, like 100 trillion atoms in a single cell? And it's said that there's probably about the same number of cells in your actual body. So if you put that together, you get this ridiculous number of atoms in your body. There's about that many, again, I don't even know how to say that number, atoms of oxygen in a single drop of water. But since we've got this ratio of 2 to 1 for hydrogen and oxygen, there's twice that many atoms of hydrogen in that single drop of water, okay? And then this kind of expands on this grain of sand idea. It says it's been estimated that there are more stars in the universe than grains of sand, but that there are more atoms in one grain of sand than even the stars of the universe, even more than just the sand, okay? Now, that made me think of this Bible verse. Let me see if I can get those to go away. I can't. Nope, won't go away. There we go. Psalm 139, verse 18, tells us that God's thoughts about us even outnumber those grains of sand. So we know how many grains of sand there are. We know how many atoms there are. And God's thoughts about us individually are even bigger than that number. Think about what consumes your thoughts the most, and it's probably the things that are most important to you. And so that verse tells us how important we are to God, and it just puts it on a scale that's just kind of incomprehensible. Okay, I'm going to also share a YouTube video for you guys that brings the scale of things to a more relatable level. Okay, so really watch that video and enjoy it, and see you guys later.